Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle. And it's called Region Sum and Quadruples Chaos by Mello Robinson. I got a hair in my mouth. That was weird. Still there. Anyways, we have chaos construction rules where we need to divide the grid into 9 orthogonally connected regions and fill every cell with a digit from 1 through 9 so that there aren't repeats in any row, column, or region. So what is an orthogonally connected region? It's a region where you can go from any cell in that region to any other cell in that region just by going through edges, all while staying within the same region. So for example, this is a valid orthogonally connected region because to get from any cell in this region to any other in the cell in this region, you can go through just edges while staying within the region. So for example, to get from here to here, you go along these edges and it'll be able to stay within the region that way. What is an example of an invalid orthogonally connected region? It's something along the lines of like this. So like these two cells can get to each other by just going through edges, but they can't get to the other cells in the region by doing so. They either have to go through a corner or they have to go through an edge but exit the region while doing so, and that is not allowed for orthogonally connected regions. And that's an example of how orthogonally connected regions and chaos construction work. We also have region sum lines, where region borders split a blue line into segments, and every segment on the line has the same sum. And disconnected segments in the same region are summed separately. Every line must crosses at least one region borders, and different lines may have different sums. So say this was a different region here. Let's do that. Then the sums on this line these are broken into a segment, and these are form a segment, and these three cells must sum up to the same sum as these two because of the way that the region sum lines work. And every line is going to have to be split into separate segments. Because the lines cross at least one, every line crosses at least one border, and different lines have different segments, so keep that in mind. But we could have something like, say, 3, 2, and 6 here, and then this could be, say, 5 and 6. And this would be valid because 2, 3, and 6 add up to 11, and 5 and 6 add up to 11, so they sum up, these segments sum up to the same sum. And finally, we have quads, where digits in a white circle must appear at least once in the 4 surrounding cells. So, for example, around this quad must appear a 2, a 3, a 6, and a 9. So this could be 2, 3, 6, 9. Around this quad, 1 has to appear at least once in one of the cells. But we could have 2 1s here. So we could have a 1 here and a 1 here. That would be valid. As long as we have 1, 1 in the 4 surrounding cells around this quad, it is valid. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, surrounding the quads that have 4 digits in them must be exactly those digits, right? Because one digit of each of those must appear once in the 4 cells surrounding those circles. And since there are 4 digits in there, those 4 digits must appear in those 4 circles. So this has to be 1, 2, 3, 4 here. This is 1, 2, 3, 5 here, and we have 2, 3, 6, 9 here. We also have 1, 2, 3, 4 here. And those are the only sets of 4 digits that we have. But around this quad, these digits cannot be 8 or 9. So where are the 8 or 9? They must appear here. So this is an 8 and 9 pair here. Okay. And since these digits add up to 10, and this digit must be 8 or 9, and it's going to be split up into multiple sections. It's either going to be 2 sections or maybe 3. It's actually, no, it can't be 3. Because we know this is 8 or 9, no matter what, by itself, at least. And since it's 8 or 9, these either have to add up to 8 or they have to add up to 9 if you're going to break it up into 3 sections. But this only adds up to 10 for 4 digits. So that's not going to equal the same as 8 or 9. And you can't have it broken up into 3 sections, with this being like 2 digits here and 2 digits here, because 2 digits here at most adds up to 7. So we're going to have 10 plus 8 here. At 19 actually is never going to work, because 19 is not divisible by any other digit except for 19 and 1. So and we know every line crosses at least one region border, so there are at least 2 segments on each line. Therefore, this must be an 8 here, and this must be a 9. Also, surrounding this quad, we can't have 1, 2, 3, 4. So so this total adds up to 18. 8 is not going to ever be able to be by itself to add up for 3 sections or segments. So it's going to have to be 2 segments adding up to 18, which means that each segment must be equal to 18 divided by 2, which is 9. So this has to be 8 and 1, and the rest are 2, 3, and 4. So this is 8, this is 9. Surrounding this quad, one of these is going to have to be 1 through 4, so this must be 5, 6, or 7. That means around this quad, where are the 8 and 9 going to be? 8 can't be here because of 8 in the row, so this must be 9, and that makes that 8. And so this sum of these digits add up to 20, right? 1, 2, 3, 5 is 11, plus 9 is 20. And 20 is not divisible by 3. We can't have a form, and we can't have a segment that's going to be less than 9, because this is 9 here. So 9 plus... that means it has to be 10 and 10 adding up together. So this must be 1 here, which leaves this not as 1 here because of 1 in the row. That eliminates 1 in the rest of the row here. So where is the 1 surrounding this quad? Cannot be here or here because of 1's in the row and column, so 1 has to be there. That means this can't be 1 there. We also know that boundary-wise, okay, let's draw the edge of the entire grid. And we know this must split this way, because we have to have 10 here and 10 here for this to be region border. So that's a boundary also, because these are all part of the same region. So there's no boundary here or here, and there's no boundary here. We have the same thing here. We must have a border going that way, because we have 9 here and 9 here, adding up to the same sum. What are these digits adding up to here? We have all the digits from 1 through 9. So it's going to be 45 is the sum, because we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to have to be, so 9, it could be divided by 5. It could be divided by 5, it could be divided by... it can't be divided by 9, because we have a 9 here and an 8 here. And 8 and 5, so 8, the segments are going to have to be greater than 8. They're going to have to be greater, they're going to have to be at least 9, because we have a 9 here. But these 2 digits, at minimum, have to be 8 and 5, which adds up to 13. We can't be divided by 4 as segments. And so it cannot... okay, so what happens... can't be divided by 2. We have 45 on this line. It's total. 45 can't be divided by 2. Can't be divided by 4. Can't be divided by 6. So the only possibilities are divided by into sets of 3 or sets of 5. And 5 is not going to work because this is going to be at least 8 and 5 as a segment. So it's got to be divided by 3, which means each of these sets must add up to 15. So it has to be 8 and 7 here, and then that's a segment. Then we have 5, 6, and 4, and that's a segment, and 9, 1, 2, 3, and that's a segment. So we know this is a different segment here. This is 8 and 7 here. That eliminates 7 in the rest of this quad. This must be 4, 5, and 6. That eliminates 4 in the rest of this quad. This is 2, 3 as a pair. That eliminates 2, 3 in the rest of the row, so no 2, 3 here. It's 5. That eliminates 5 in the rest of the quad because we have 4 cells in that, 4 digits in that quad. So here, there's no boundary. Here's no boundary, no boundary here, no boundary here, here, here. So there must be a boundary here because this is a separate, these are the same region, and this has to be a separate region than that. Okay. 5 cannot be here because of 5 in the row, so where's the 5 surrounding this quad? It must be there. We have to have a 5 or 6 here. We're not sure where. 9 eliminates 9 here. Where's the 9 then? It has to be one of these two digits. We also have a 2, 3, 6 quadruplet in column 4, which eliminates 2, 3, 6 in the rest of the column. So this can't be 2, 3, or 6. Remaining digits are what? 4, 5, 7, 8. Yep. That means we have to have a guaranteed 6 here, which eliminates 6 in the rest of the around the quad. We have to have a 9 here. We have a 2, 3, 9 triplet also in column 5, which eliminates 2, 3, and 9 in the rest of the column. So that leaves the remaining digits as just 1, 5, 6, 7, 8. Okay. That means surrounding this quad, we need a 3, which means 3 has to be one of those two. Surrounding this quad has to be 5, 6, and 7. Well, 7 can't be here, so 7 has to be one of those two. And since we know there's a 3 guaranteed here, this must be 3 with 5 and 6. 5 or 6, I should say. And that leaves the 7 with 5 or 6 there. We have a 3, 5, 6 triplet in column 6, which eliminates 3, 5, 6 in the rest of the column. That leaves just 1, 2, 4, and 9. Remaining in column 6. This can't be 2 because of a 2, 3 pair in the row. Okay. There's no boundary between these because that must add up to 9. This is at least 7. If we have a 7 here, the problem with that is we're guaranteed the... How would that even work? We could have these two digits adding up to 1. Well, that's not going to be the same as that digit. If we have these, so if we try to break this up into a singleton, 2 digits here in the same region, and another singleton, we can't have, obviously, singleton here and here, or here and here, because they are in the same column or the same row, and there are no repeats allowed in rows or columns. So if we try to have a singleton here and here, the problem with that is these have to be the same digit, and then these two must add up to that digit. Well, obviously that's not going to work because this is 3 and 5 at minimum, and this could only be 7 at most. So 3 and 5 is never going to add up to 7. So that's not going to work. Therefore, to divide this line, it has to be 2 and 2, I believe. You can't have 3 digits here on either side, adding up to a singleton, because these digits, this adds up to 9 at minimum, and obviously this can't be 9. These digits add up to 14 at minimum, which obviously is not a single digit. So the way this must be divided up, it must be broken that way. This is 7 and 5 at minimum, so this is adding up to 12, or it's adding up to 13. Well, 3 can only add up with 9 to add up to 12, so this cannot be 3, which means 3 has to be here surrounding this quad. Also, we know there's a 7 guaranteed around this quad here, which means we are guaranteed 2 cells in rows 8 and 9 already containing a 7. So this cannot have a 7 here, and these 2 digits must add up to what these 2 digits are. And 7 and 5 is 12. It can't be 5 and 7 there. Sorry, I get the hair still in my mouth. 6, so that doesn't work. 5 and 7 would have to make 12 here, but this is never going to add up to 12 with any of these digits possible. So it has to be 6 and 7 here. That's 13, which means these 2 digits must add up to 13, so it has to be 5 and 8 here. So we have 5 here, this is 8, this cannot be 8 here, remaining in column 5. 5 eliminates 5 in the rest of the column, so there's no 5 here. This is 6, which makes that 5. That eliminates 5 in the rest of the column here. And this is 6, 7 as a pair. 8 and 5 eliminate 5 and 8 there. Where is the 5 surrounding this quad? It has to be here. Because it can't be here anymore because of 5 in the row. Can't be here because of the 1, 2, 3, 4 quad here. So 5 eliminates 5 in the rest of the column. Where is 6 surrounding this quad? It has to be here because these can't be 6 at all. Because of 6 guaranteed here, and this must be 1, 2, 3, 4 surrounding that quad. So that's 6, which eliminates 6 there, so it's 7, which makes that 6. 7 eliminates 7 here, so that's 4, and we have a 4, 5, 6 already surrounding this quad. 3 digits, 5, 4, and 6 are not adding up to singleton digit there. That's 15. And we can't have 4, 6, and x adding up to 5 here. So this must be 2 and 2, because 4 and 6 by themselves would add up to 10, which cannot be equal to 5. So these must be a boundary here, and this must be 3 and 6, adding up with 4 and 5 to add up to 9. So this is 3 here, that eliminates 3 in the rest of the column, so this can't be 3, that's a 2, 4 pair. Where's the 3 surrounding this quad? It must be here. So that's 3 there. So there's no boundary here, there's no boundary here, no boundary here, and no boundary there. Okay. Remaining digits of row 8. We have 1, 2, and 9. So 8 is going to have to be one of these 2, guaranteed. Because we need an 8 surrounding this quad. Remaining digits of row 5. We have 2, 3, and 6. Okay. Four eliminates 4 in the rest of the column. 6 here eliminates 6 here, so this is 1. That eliminates 1 in the rest of the column. There has to be some boundary surrounding that. So this quad is done, this quad is done, this quad is done. So is this quad, this quad, this quad is done. This quad is done here, so is this quad, this quad, this quad, this quad is done. We could have another 3 somewhere. We know 7 has to be one of these 2 digits here. We don't know which. 3 is done here, 5, 6, 7 is done here. We don't have enough information here yet. So here we're going to have two digits adding up to a singleton here. What are the remaining digits of column 2? So the remaining digits of column 2 are 1, 6, 7, 8, 9. This cannot be 1 or 6 because of 1 or 6 in the row. So can this can never be 7 because one of these is 7, so this can't be 7 here. It's 8 or 9. And this digit is definitely going to be greater than this one. So that means this must sum up to the same sum as these two. And we can't have 1 here because of 1 already in the row, so it must be 9, 7, and 2 adding up to 9, right? So this is boundary here. There's no boundary between those two. 7 eliminates 7 here, so that's 8. That eliminates 8 in the rest of the row. 9 eliminates 9 in the rest of the column. Remaining digits of row 9 are 4, 5, and 8. And this 3 has to be separate from this region because this has a 3 and this has a 3. And we can't have repeats in the region, so this is a boundary there. Okay. This is the same region with the 4. So this has a 4 and this has a 4, so they must be different regions. Same with the 1 here and the 1 here. And again, this is no boundary here because the 1 and 8, 9 adds up to 2, 4, and 3. So these must be different boundaries. Hmm. Okay, 2, 4, and 3. How is this going to be broken up? We can't have a singleton here. If this is for 9, this could be 3, 6. It can't be 2, 3, whatever, because 2, 3, 6 is already 11. So it would have to be, if this were 9 as a singleton, it would have to have 3, 6 there. But the problem is these two digits never add up to 9 with any combination of digits because of the 2, 3 pair that's here. 5 also eliminates 5 here. Remaining digits of this. Let's do remaining digits of row 6 and row 7 because there are some lines there. We have 2, 3, 4, 7, 8 as possibilities. And obviously you could have an 8 here. 7 is 1. Can add 1, 2, 4, 7, or not 6, 7, 9. So no 6, 7 here because of 6, 7 in the column. No 7 here because of 7 in the column. Okay. There's going to have to be a boundary here somewhere. We could do something like that. That is potentially possible. This can't, or it could be 8. We could have 8, 8, and then these are 2 digits there. That is possible. Okay. Oh yeah, we're looking at this line. So 9 cannot be a singleton by itself. 2 and 3 obviously can't be a singleton by themselves because then these would not add up to, this is already 6 here. So these two have to be in the same region, guaranteed. We don't know anything else though. Um, this section has to somehow go out this way. Because it's blocked by a 5 here. It's blocked by this 5-8 region here. So it's going to have to go out somewhere here. Either from this cell or this cell. Hmm. Can this 3-6 ever go this way? That is not connected to the 2 and 7. I think the answer is probably no, right? So if we try to not go this way as a 3-6, that means this is a boundary here. So it has to go out this way. But that's 1, 2, 3, 4, 5, 6, 7 regions. And there has to be a boundary here. And it's not the same region as this region that has a 3. So it cannot be going that way. Therefore, these are part of the same region. So 2 and 7 are not part of the same region as 4 and 5. 1, 2. So if we tried going out this way with the 3-6, the problem is this 9 doesn't have a full region to be part of. So I don't think it can be part of, it's not part of the same region as 9 because we have a 2 there. Therefore, this region must get out. And so it has to go this way at least, because these are part of separate regions. Therefore, this is blocked as a boundary there. This has to be part of a region. We cannot be part of the 3 here. So this is a boundary here, which means it goes to the 8-5 as a separate region. One, 2, 3, 4, 5, 6, 7. We need access to a 7 and a 9. So it has to be here. And this must be 7 here and 9 here. That eliminates 9 in the rest of the column. 7 eliminates 7 here. So that's 6. Therefore, this is boundary there. Blue, this has to go out that way. So this is part of the same region there. This has to get out this way. This has to go out that way. This is going to be blocked by some line here, so it has to necessarily include these. So it's 1, 2, 3, 4, 5, 6, 7. We have 2, 4 already in the region, and 3 and 9. So this can't be 2 or 9, it's 1. This can't be 1, 2, 4 or 9, so it's 6 or 7. And 4 eliminates 4 here, so it's 5 or 8. Can it be 3 digits here adding up to another digit? No, because this is at minimum 1, 2, and 6, which adds up to 9, but 9 cannot be here. So this must be 2 digits here and 2 digits here, which means that's a boundary there. So this must include the 5 there to go that way. So this is, oops, this is part of red. Actually, let's make this, instead of green, let's make it, let's make this orange, and we'll make this pink. This has to be green going out that way. It could be part of this. So these 2 digits add up to what these 2 digits do. 5 eliminates 5 in the rest of the region. Wait. 1, 2, 3, 4, 5, 6, 7, 8. That's too small. So that means we have to go up 1. So this is the boundary there. So then this becomes red there. No 1, 8 there because of 1, 8 in the row. It's 6 or 7. We have a 6, 7 pair. 5 eliminates 5 here, so that's 8. Green has to go out this way. This can't be medium. This must go out this way. It could be all green here. That is possible. We'll make it light for now. This has to be a different region than the 8 here. So that's a boundary. So this adds up to 7 here. 7 eliminates 7 here. So that's 6. That eliminates 6 and 7 in the rest of the row. We can't have 9 in the rest of the row. So 6 is here, which means this can't be 6. It's 7. That eliminates 7 in the rest of the column. 6 and 8 eliminates 6 and 8 here, so that's 1. No more 1 remaining in column 2. 1 eliminates 1 here, so that's 4. 4 eliminates 4 in the rest of the column. So this is 1 and 6, which adds up to 7. Therefore, these two digits must add up to 7, and the only possible combination is 3 and 4 here. So that's 3, that's 4. 4 eliminates 4 here, so it's 2 and 4. 2 and 4 eliminate 2 and 4 in the rest of the row. 4 eliminates 4 in the rest of the row there, so it's 1, 2, 8. Okay, remaining digits of row 4, we have 4, 6, and 9. And this can't be 4 or 6, so this must be 9. So they have to have, can't be 6 here because of 6 in the column, so that's 4, which makes this 6. That eliminates 6 in the rest of the column here. 3 eliminates 3 here, so that's 2, which makes this 6. Okay, 2 eliminates 2 in the rest of the column. 1 eliminates 1 here, so it's 2. That eliminates 2 in the rest of this row. One eliminates 1 here, so this is 9. That eliminates 1 and 9 here, it's 2. 2 eliminates 2 here, so it's 3 and 2. We have a contradiction. Ugh. How did I get to that contradiction? That's weird. Oh, 7. That's where I messed up. Okay. Okay, well, at least we found it quickly. That's a pretty bad error. Man, what are we missing then? We're missing a 4. We're missing 4 and we're missing... Okay, that's a pretty bad contradiction. We're missing 4 and 9. So yellow has to go this way. For the 4 and 9. Okay. And this 9 eliminates 9 here, so that's 4, which makes that 9. Okay, that's still the same. No 4 or 9 here, no 4 or 9 here. 4 eliminates 4 here. So that's 2 and 4 there. Again, red is going to be blocked by some boundary here. So this must go red this way. We can't have all 3 of these adding up to a singleton there. Actually, no, because this cannot have 2 here. No 2 or 9 here, it's 1. That means no 1 here. No 4 here, because of 4 in the column. So this is done as a boundary. This still does have to go out this way. Because it can't go this way because we already have a 5 in that region. So this must go that way. This has to go still out that way. This still has to go out that way. There's no other place, but we're now blocked there. 2 eliminates 2 in the rest of the row. No more 1 here. 6, 7 as a pair. That eliminates 6, 7 in the rest of the row. How is this going to work? We can't have 8 and 8 here. 4 and 5 eliminate 4 and 5 here, so that's 8, which means this can't be 8 here. That's 4, no 4, 8 here, it's 5. How does that work? Oh, it's going to be 5, 2, and 1 adding up to 8 there. That's the only way that that works. 4 eliminates 4 here. Also no 4 there. No 1 or 8 here. We don't know about that. So this does... It cannot go back here because then these would be the same... Well, this would be blocked from forming full region. This can't be part of that because we already have 1 and 8, so this must go that way. So again, we have to have green here because we can't have 3 digits adding up to a singleton there. That was a pretty big mistake anyways. This still has to exit out. Could still be green. We'll mark it as light for now. Okay. So adding up, we don't have 4 available here anymore. So how would we add up to 7 here? Can we? 1 and 6 would force 2 and 5 or 3 and 4, but there's no 2 or 5 or 3 or 4 available. So this can't be 1, 6. It must be 1, 7, which means this can't be 7. That's 6. So it can't be part of the orange region. It's part of the pink region. Okay. So this must add up to 8. No 3, 5 is available, but we do have 2, 6. So then we could have 2 and 6 here. That eliminates 6 in the rest of the row here. That eliminates 2 in the rest of this row here. Um, 7 here eliminates 7 in the rest of the region, so that's 6. This is done as a region. Remaining digits of row 4, we have 4, 7, and 9. And 7 can't be here because of 7 in the column. Guess we don't really have more information. 2 and 3 eliminate 2 and 3 in the rest of column 8 as a pair. So this can't be 2 here. It's 9. This can't be 9. It's 2. We can't have 2 here. Or sorry, this can't be 3. So this must be 5, 2, and 1 adding up to 8. So we have boundary there. So 5, 2, and 1 adding up to 8. 8 eliminates 8 here, so it's 7. That means this can't be 7 there. Okay. Remaining digits of column 1, we have 3, 4, 5, and 9. This can't be 3 because of the 2, 3 pair in the row. 6 eliminates 6 in the rest of the column. If this were part of the same region, that's not going to work because we need access to a 3 for the green region. And this can't be 3 because of a 2, 3 pair in the row. This can't be 3 because of 2, 3 pair in the row. And this can't be 3 because of 3 in the column. So these are different regions. Okay. Let's see. How did these add up? So we could have a singleton there. 5 works, and it could be 4 and 1. Or 9 might... No, 9 doesn't work as a singleton. Interesting. Remaining digits of column 3, we have 4, 5, 7, 9. Green needs access to a 3. It's going to have to be one of these. You could have 4, 3, and 1 there. That does actually kind of work. Remaining digits of column 8, it's just 1 and 6. So pink needs access to an 8 and a 7. I mean, that satisfies this exactly. assuming this is not part of blue, could this access another 5, 2, and 1? The answer is no. It would be blocked by this 7. So this must be part of this region here, which means 8's not part of it. So then we need access to an 8. It can only get access to an 8 from there. So then this is done as a region. So then this must be 8, which makes this 3. We have 8 and 7 here. This is 4, 5, 6, 3. We need access to 1, 2, 9, 7, 8. It can't be a part of this region. The only 1 and 9 can only be part of that. And these are different region because of the region subline. So this is not necessarily a border. The only 7 and 8 it can access is this, and therefore it must access the 2 by going that way. So this is 2 here, that's 3, which makes that 2. 2 eliminates 2 here, so that's 3. This is part of a different region than this. So this has to go out this way, because this has a 3 in it, and we have a 3 in this one. Okay, remaining digits of column 9. We have 4, 6, 7, 9. Okay. If we just contain these two, the problem is these would have to be the same digit because they would be broken up into segments there. So we cannot have 8 going there and then 7. We can't have 8 going there then 7 because that would block this from being a full region. So this has to be pink. So that's done as a region. I guess we'll make this medium size. We are going to, well, don't have to go that way. We are guaranteed a 6 here. Oh, that's interesting. We are guaranteed a 6 here in column 3. We're guaranteed a 6 here in column 8. That means there are no more 6s available in these rows, because that's 2 cells already accounting for the 6s. So it cannot be 6 here. Where is the 6 in column 9? It has to be here. That eliminates 6 here, so it's 7. That eliminates 7 in the rest of the row, so this can't be 7. That's 1. 1 eliminates 1 here, so that's 4. No more 1s here. No more 4s here. I think it has to be 4 and 7 are part of a region. Yeah, because 4 can't be a singleton by itself. 4 and 7 already adds up to 11. So it's going to have to be 3 digits adding up to 2 digits. And one of these is a 6. So right now I can see 2, 3, 6 adding up to 7, 4. That works. What about if we try to have 2 here and then 3 here? 6, 7, 4 is already too large for these 2 digits. So 6 would have to be here. 6 and 9? 6 and 3 is already smaller than 7 and 4. So 6 and 9 is 15. And 15 minus 7 and 4 is another 4, which is not possible. So then these have to be the same region, and then the boundaries are these and these. So this must be 2, 3, and 6, which means 9 can't be here. Therefore, 9 must be here. That eliminates 9 in the rest of the row. 4 and 7 eliminate 4 and 7 in the rest of the row here. So it's 5, 9 as a pair. This is a boundary here because this already has an 8. These are separate digits than these. This has a 6, so this cannot be part of this dark set here. And it has 2 and 3 already has this. So this can't be part of this set here. So it must be part of the light set, I'm guessing. 1, 2, 3, 4, 5, 6, 7, 8. And then these, so because it can't be part of the medium set, can't be part of the dark set, it has to be part of the light set here. And it's going to have to be 2 greens that way. So it's going to have to be green going around here. And then this, because this needs to be splitting. A region border must be, every line crosses a region border. So this has to be a region border here, and light can't go any further here, so it can just go there. So then green has to go this way. That's 1, 2. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that works. 1, 2, 3, 4, 5, 6, 7, 8, and 9. That works there. So we have boundaries there and there. So these are part of the same region. Can this ever be dark? No, because 4 and 7 would eliminate all possibilities for that cell there. So this must be medium, which means medium extends to here. One of these is going to be medium. It can't be that one, obviously, because dark already has a 6. So then medium cannot go this way. 1, 2, 3, 4, 5, because one of these 2s is not part of medium. We can't go this way to medium, so this has to be, well, we know this has to be medium, because 1, 2, 3 cannot extend too far that way. We need access to a 9 for medium. It can't be here or here, so it must be accessed that way. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Dark has to get out somewhere, so this can't be 6 because of 6 in the region. So that's 1, that's 6. 1 eliminates 1 here, so it's 2 and 1. 2 eliminates 2 here, so it's 3, which makes that 6. That leaves that as 2. 3 eliminates 3 here. 1 cannot be part of the dark region, so this must be medium. And that's done as a full 1, 2, 3, 4, 5, 6, 7, 8, 9 cells for the medium gray region. So the rest is all dark. Okay, so these add up to these digits. We guarantee this must be a 3. So this cannot be 9 here, because 3 and 4 add up to 7, and 3 and 5 add up to 8 there. Remaining digits of column 7, we have 5 and 8. Okay. Two eliminates 2 here, so this is 3, which makes that 2. We don't have... Okay, light already has access to an 8, so this cannot be 8, which makes this 7, which makes that 8. So 7 plus 3 is equal to 3 plus 4. That eliminates 4 there, so it's 9 and 5. This can't be 4, 5, and 9. It's 7. 7 eliminates 7 in the rest of the row, so this is 4. No more 4 or 7 here. It's 5, which makes this 9, which makes that 4. No 4 or 9 here makes that 7. No 4 or 7 here makes that 9. And 8 eliminates 8 here, so it's 5 and 8. And that's a solution. Yeah, not too bad for a chaos construction rule set. Definitely challenging, but it's fine. I just messed this portion up there. That was a pretty bad mess up. We already had a 7 and a 6. Anyways, yeah, probably one of the easier chaos constructions you have. Very cool, though. It worked out very well. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.